Hey, wow, okay. So I apologize for the delay this morning. Zoom is having some issues. Apparently it's not on Santa Fe's end, but it is actually on Zoom's end. But I'm really glad to see that everybody is able to get in, or at least that those of you who are here were able to get in. And again, yeah, sorry that the link was a little bit late. I want to remind you all that I am recording this and that the recording will be posted to YouTube. So if you don't want to be seen, you can keep your video feed off. When I transition to writing on the dot cam, then you can turn your video feed on without fear of appearing in the recording. But for now, when I'm not doing any screen sharing, if you don't want to appear in the video, please keep your video feeds off. Today we're going to do a handful of things. Most of the time, what you will see is this, which is my document camera, and this is MAC2312, section 002. This is a lecture from 8/24/20. And today we're going to do a few things. We're going to go over the syllabus. We're going to try to pick some office hours. And I'll talk with you about exactly how the office hours will work. We're going to talk about WebAssign. Let's see, is there anything else here besides that stuff? I think that's about it. So then we're going to talk about, we're going to begin some actual math. We'll begin these sections in the textbook. WebAssign, I guess we'll be talking about the text too. Okay, so this is roughly what we're going to do, and this is pretty much how we're going to start every day. I will always have this header at the top with the date and our class and section number, so you know you're in the right place, and we'll always give a brief overview of what it is we're going to do in that lecture. So first things first. This is our Canvas class, and hopefully, obviously you're here, so you made it to the announcement. So either you clicked on that through your email or Canvas messages, or you've actually navigated to this page before. Hopefully you've navigated to this page at some point. The home page here takes you to the syllabus, right? So the syllabus page and the home page in Canvas are the same thing. At the basic class information, my name is John Filesticker. You can call me John or Professor John. I know my last name is weird, so don't stress about it. If you haven't yet, do me a favor and click this link, which says click here to access the full syllabus, and then save this somewhere on your computer. So I recommend having a folder somewhere on your computer, however you organize your file structure. So on my desktop, I have a Fall 22 folder. I'll go ahead and create a folder for this class within it, MAC2312.002. And then inside that folder, let this be the first thing you save. There will be several times through the semester where you have to scan and upload things, and it's a good idea to keep records of those in that folder. And there will also be times where I write out comments and scan things back in, and you'll want to download and save those into that folder as well. That way you can keep track of all the stuff that we do. Oh no, I don't want to look at it in the browser. Let's do this. Okay. So here's my folder where I saved that syllabus. It's a PDF file, so it'll open in whatever your default PDF reader is. I recommend using Sumatra or Adobe. I do not recommend viewing PDFs in your web browser. If your web browser is your current default application to view PDFs, I strongly encourage you change it. Adobe has a free version. My favorite piece of software for this is called Sumatra. Looks like this. In any case, you should be looking at the syllabus for our class. We're going to talk through this somewhat carefully. That way, later in the semester, when you ask me lots and lots of questions, I can be like, it's in the syllabus. No, realistically, we're talking through it so that hopefully you don't have those questions later. So this is my name. This is where my physical office is, A031B. That's downstairs on the north side of building A in Unit 2. But of course, right now, you can see I am at home, just like the rest of you, because COVID. This phone number rings in my office, and I do have that forwarded to my cell, but I do not have any sort of way to use caller ID or voicemail. So if you leave a voicemail for me at this number, I won't get it for a few weeks until I go into my physical office and check my voicemail there. I can't check those remotely with the forwarding system I have. So if you need to get a hold of me, the best thing to do is to send me an email. Right, this is my email address. You can also send me a Canvas message. Canvas messages forward straight to my email, and that is definitely the best way to get a hold of me. You're here now, so you probably know that our class meetings are Monday, Wednesday, and Friday from 9:30 to 10:45. I know one of these is a lab, but right now in this hybrid format, there really isn't a big difference between our lab meetings and our regular meetings, although I will be trying to introduce some more labby type things in the online setting as the semester goes on. Office hours, this is one of those things that we're going to figure out today. There will be two sets of office hours. There will be these TBA office hours, the to be announced, standing office hours or drop-in office hours, where I will always be there at that time, and you can click a link in Canvas to go to that Zoom meeting and ask me questions. And these, anybody can come in, anybody can go out as they choose. If you want to meet with me either one-on-one or outside of the office hours we establish, and we'll establish them this week, you can also make an appointment. So to make an appointment for an office hour, you just send me an email or Canvas message saying, hey, I would like to talk to you about these things at this time. And then I'll send you a Zoom link saying, okay, that sounds great. I'll meet you at this Zoom link at this time. The final exam for our class is 8 to 10 a.m. on Wednesday, December 9th. I would put this in your phone's calendar with like a 1-day warning and a 1-hour warning right now. It's not our normal class meeting time, right? It's earlier. So it's a place to make sure you're a little bit extra careful. The prereq for this class, you're here, so you obviously did that. The textbook for this class is Stewart's Calculus. We're on the 8th edition now. And it's important that you get the early transcendentals version. This means that you introduce functions like e to the x, natural log x, sine x, and cos x early on, which is critical. So the early transcendentals version is the only version you should consider. This is the ISBN 13, if you want to search by ISBN. The calculus book looks like this. When you register in WebAssign, which is necessary because that's where the online homework is for this class, you will get access to an electronic version of this book that looks like, looks like this. I happen to kind of hate the electronic version of the book that is in WebAssign. It's got some advantages, and there's some nice things about it. It does have like some embedded videos and things like that. But if, like me, you loathe this thing, then you either want a physical copy of the book or a more usable electronic copy like this PDF that I have here. This PDF, I don't even remember where I got it. I've had it for years and years, but I assure you I didn't pay for it. So if you search around online, you can find PDFs like this. If you're having a hard time finding an affordable copy of the textbook, whether you want a hard copy or a nice PDF soft copy like I have here, send me an email or Canvas message. I can help you find a cheap or maybe even free to you copy of this book. Okay, let's go back to the syllabus. The next thing here is WebAssign. So I think most people have probably used WebAssign at some point before. Oh no, yeah, a bullet point here that's supposed to be separated didn't separate. Anyway, WebAssign. It's where the homework will be. It looks like if you go to our Canvas page, I'll pretend like I've not gotten in here. If you go to our Canvas page and you click on the WebAssign link, it'll take you here. You can click here to go to enter class key, or if you already have an account with them, you can click here to go to login. Login, I've already got my credentials here. If you don't have an account with them, you can go here to enter a class key. If you do already have an account, go ahead and put it in. And then later down the road, it will ask you for a class key. When it asks you for a class key, this is what you feed it. This is the class key to get into our WebAssign class. You will need to buy an access code. I think the access codes are somewhere in the neighborhood of $100. If you don't have an access code yet, you can sign up with a trial access. Oh, Daniel says he's not getting any audio. Are other people having a hard time hearing? Yeah, Zoom definitely is shitting the bed really hard right now. Okay, so it seems like most people can hear. I am recording this and I'm recording it on my local computer. So the video will have all the audio correct when I upload it to YouTube. I'm sorry if you're having trouble with Zoom right now. I totally understand. Do your best to follow along, and if you have questions, type them in chat. So maybe I should, if people are having trouble with audio, I should type that. All right, if you are having audio problems, all right. Calculators, right? So I used to say you can use any scientific calculator as long as it, doesn't return exact values for things like the sine of pi over 3 and whatnot, but the department has cracked down on that. The only calculator you can use on a test is this one, the TI-32XS. So it's 30 and then 2 I's, so second edition XS. That one is kosher on tests, but no other calculators are. You will not need a calculator on the test. The tests are written in such a way that the arithmetic is trivial, and anything that the calculator could help you with for trig wouldn't be giving credit for anyway. I require exact answers, and the TI-32XS can't give them. So you don't need a calculator, but if one makes you feel more comfortable, this is the only one you're allowed to have during a test. Graphing calculators, calculators capable of symbolic manipulation, straight up not allowed. Cannot use graphing calculators or anything like the TI Inspire that's capable of doing symbolic manipulation. Another thing that you will need is a computer with an up-to-date web browser. That's for, WebAssign, Zoom, Canvas. You're gonna need consistent internet access. I know that some people, if you live like a little bit out in the boonies, or you're using a satellite internet or a mobile thing, that can be a problem. So make sure that you make plans, especially when it comes to the test days, because our tests are proctored using HonorLock, and HonorLock will get upset with you if you lose internet access, even just for a second. So you need to have consistent internet access that's good enough to stream video in 2 directions simultaneously. So you want something like, I don't know, like 40 megabits. A functioning webcam, also necessary. Again, for HonorLock, I don't care if you don't have a video feed displayed during our lectures, but for HonorLock and for our little Zoom meetings, like in office hours and stuff, there I really do need to be able to see you. And the HonorLock people need to be able to see you and what's going on in your room, so you do need a working webcam. If you're having a hard time getting access to any of these things, send me an email or a Canvas message. The math department does have like loaner laptops that they can give you for, I don't know how long, like a day or 2 at a time to take tests and do things like that. Course description, so this is Calc 2. It's the second in the 3 calculus classes. We focus on skill building and problem solving, and the main things we're gonna talk about are integration. So how to integrate a whole bunch of shit, things that we didn't know how to integrate at the end of. Look at some applications of integration where you can find like, things in physics like work, things in statistics like average value, or things in geometry like volume and surface area. We're going to talk about sequences and series, and this is the part of the class that most people start getting scared of, sequences and series, because we're not talking about continuous functions anymore. It's kind of a departure from what you're used to in your algebra and calculus classes. We're going to be talking about what are called discrete functions, sequences, which are really just lists of numbers. And then series, which is what you get when you add up a list of numbers like that. Even though it's infinitely long, you can still add them all up. Power series, which are like series, but with variables in them. So we use those to represent functions. Turns out most functions can be written as an infinitely long polynomial. That's kind of mind-blowing on its own. But a power series is really an infinitely long polynomial. And then we learn how to get a function and then write it as a power series. After that, we will be done with the super scary part of the course. We'll talk about parametric curves and polar coordinates. Those things people don't usually find too terrifying. If you want a full list of all the course objectives, you can click that little cyan colored link, and it'll take you to Santa Fe's little page here with the full list of course objectives. Cell phone policy, this is more relevant in in-person classes, but you know, DBAA, just be polite. Don't use phones or any other tech in a way that distracts people. And of course, no phones or other smart devices during exams. That should go without saying. Attendance. So I will be using Zoom's chat log to take roll. Make sure you type something in the chat log at some point. I would prefer if you did it right at the start of class, but I think I can also pull out an attendee list. So don't stress too much. I'll be using Zoom to take roll every day, and that's more for financial aid purposes than anything else. There is no attendance component to the grade. You know, I'm not going to take off points if you miss a class. You don't need to worry about that or coming up with excuses for missing a class. But I strongly recommend that you attend every class. Right? If you miss a class, it hurts you. So if you do happen to miss a meeting, first make sure that that you watch the recording when I post it. And second, I would encourage you to reach out to me and talk to me a little bit about the material that you missed that day. So yeah, what you guys are doing in chat there is fine. You can go ahead and type here if you like that. That'll give me a convenient place to look and see everybody's name. Makeups. So if you miss something, if you miss a test, if you miss a homework, if you miss a study guide, you gotta talk to me. You gotta let me know what's going on, preferably before you miss the thing. But I tend to be very loose about this. I'm happy to extend homeworks. I do not mind doing that at all. Study guides, we'll talk about a little bit more as they get closer. Exams, if you're going to miss an exam, you need to tell me. If you miss a test, pretty much regardless of the reason why, I will schedule a makeup for you. But you gotta talk to me, you gotta communicate with me, and the makeup has to be scheduled within a week of the missed exam. Cannot go beyond that. My makeup tests tend to be a little bit harder than the original tests, so you want to be aware of that as well. But I don't usually fight over it. You know, if you miss something, I'm happy to do a makeup. Just talk to me and we'll get it figured out. Homework and study guides. So every week, including this week, there will be a homework set on WebAssign. The homework on WebAssign is coming from problems that I talk about in class. Each Monday after today, there will be a homework due. So today, a little bit after class, I'm going to release your first homework on WebAssign, and it will be due at the start of class next Monday. So that's the homework. You have one homework set per week. They open on Monday, and they are due at the start of class the following Monday. A little bit over a week before each midterm exam, I will send out a study guide. Those will be like some particular problems from the homework or good problems that I liked in WebAssign. And you guys have to write out nice, neat solutions. So not only do you need to complete the assignment in WebAssign, but you need to write out and show all of your work. Then you're going to scan that work and submit it to me in Canvas under the assignment study guide, whatever, study guide 1, study guide 2, study guide 3. I'll post really clear instructions about this when we get a little bit closer to the first exam, but it is your written work that I grade for the study guide grade, and we'll talk about those when we talk about the grades down there. The main point here is that when you're writing out those study guide solutions, you should be pretending like you're working on a test problem. And you should share your solution with your friends. You should share your solution, especially with me, so we can talk about your notation. We can talk about any algebra mistakes. We can talk about anything that maybe your Calc 1 professor did wrong or didn't show you. And you should show me and other people that work before the test, right? If you show me your work and I say, oh, well, you're not writing dx's here. Oh, square roots don't actually quite work like that. then we can talk about it and you'll get a better feel for how I'm gonna grade your shit. I'll get a better feel for your styles, and I can let you know anything that you're doing wrong or anything that I would take off points for. So you really wanna work these study guides as soon as they come out, and then talk about the problems with your classmates. I strongly like a Discord or a GroupMe, something like that is great. And also maybe email 1 or 2 of them to me, or show me 1 or 2 of them during an office hour, so I can give you a little bit of feedback before the test, because you don't want your first critical feedback from me being the exam. It's nice if we can both get to know each other's styles a little bit before you're in such a high pressure situation. Lab meetings. So usually in my labs, I have students come to the front of the class, solve problems, and then each correct problem solved is an extra credit point on the next midterm. Of course, we cannot do that in Zoom. It's a little bit frustrating, but I'm trying to figure out a nice way to do it. For now, the labs, don't worry about them, but if I get a system work together here that I like in Zoom, we'll go back to something like that. For now, just think of the lab meetings as another class meeting. Exams, they're going to be 3 midterms and 1 cumulative final. So 4 tests altogether, 3 regular midterms and then a final. The midterms are going to be in Canvas, and they're going to be proctored by HonorLock. So if you've taken a class with me since this COVID shit started, same thing. Otherwise, yeah, HonorLock is something you might want to play around with a little bit, and I'll post again instructions and all sorts of stuff on Canvas when we get close to the first test, explaining how to use HonorLock. But you need a webcam, you need Chrome, and you need to install the HonorLock Chrome extension. The exams will be hosted inside Canvas as Canvas quizzes. They're very easy to access and very intuitive to fill out. So I'll give you lots of detailed instructions as we get closer. The tests are going to be during our normal class meeting times. So I'm trying to make this as similar as I can to a regular in-person class, which means that on the day of the test, instead of coming to a Zoom meeting, you're going to sign in to HonorLock on Canvas and take the test there. And it'll be during our regular class time. I might add like a 30-minute window on either end to help deal with any tech problems, but again, we'll talk about those details when we get closer. The final is also going to be in Canvas, but it's at this day and that time. So make sure you get that changed. Is that the same there as it is here? That's me, final exam. Oh, no. All right, so this, I think this final exam time is wrong. Let me double check. So you guys, you know, yeah, I think it's 8 to 10. Yeah. So ignore this time in the syllabus. This is a copy paste error, but yeah, your final is 12/9 from 8 a.m. to 10 a.m. So the info up here is correct. I don't know how that got through. All right, other important stuff. I am recording these things, so be aware of that. I'll be posting them on YouTube, so be aware of that. These are some dates that you want to put in your calendar, like right away. If they're not in there yet, go ahead and grab your phone out, put them in now. The especially important ones, today, of course, classes begin. Last day to get your money back. You decide, you know, you hate this format, or you hate me, or you hate calc, or whatever. You just don't want to do this right now. I totally understand. Last way to get out of here with your money back and nothing on your transcript is the 28th, which is this Friday. Labor Day, college will be closed, so we will not have a class meeting on that day. I think that is a Monday. The 31st, Halloween, is the last day you can get a W. So if you know, you decide things are not going well, you need to bail, the last day you can get a W on your transcript instead of an A through F letter grade is Halloween. The 11th of November is Veterans Day. We are closing for Thanksgiving. 12/4, December 4 is the last day of class. 12/9 is your final, again from 8 to 10, not from 1 to 3. And then grades will be up on the 13th of December. The grade breakdown is here. So most of the grade comes from the tests, but about 8%, Hammy, no Bubba. Don't eat the cat food. All right, that's my greedy dog. So about 8% of the grade, or 45 points, comes from the homework on WebAssign. About 13% of the grade, or 25 points each, 75 points total, come from the study guide. And this grade is for your written work that you scan and submit in Canvas. All right, so you have to write out those solutions, scan and submit them in Canvas to get credit for the study guides. It's an easy 13%. The midterms make up a little bit more than half of the grade. Each one is worth 100 points, and there's 3 of them. The final, all on its own, is worth a little more than a quarter of the grade. So you see more than 75% of the grade, more than 3/4 of the grade in this class comes from proctored tests. In the event that you absolutely bomb a midterm or something happens and you are unable to take the test and unable to make it up, the final will replace your lowest midterm if the score on the final is higher. So Davis is asking what I mean about the scans for the study guides. So for the study guides, I will be posting, I'll show you here in WebAssign. So I'll post an extra homework that'll be titled like Study Guide 1 or Study Guide 2. You'll have to complete that homework in WebAssign. That'll be a part of your homework grade. But then in addition to that, you'll need to write out nice, neat, careful solutions on paper for each of these problems. Then those solutions that you write out on paper, you will scan using an app like Cam Scanner on your phone or a physical scanner if you have one, and you'll submit it as an assignment here. So you see for Study Guide 1, you would, in order to submit this assignment, you would come in here, and I'm not looking at the student view right now, but you have the option to submit a PDF. So you need to write out the solutions to those problems from WebAssign, and then scan them using your phone or a physical scanner and submit the scans here. And it is that scanned written work that I will be grading for the 25 points or for the 13% here. Does that answer your question, Davis? Is that clear? Cool, cool. All right, so you don't need to print anything. You can just handwrite them and scan. The next page of the syllabus is all kind of boilerplate required Santa Fe stuff. So GELOs, General Education Learning Outcomes. These are some things that the state asks us to track. So there will be a few questions on a few tests. If you get them right, you get the GELO. If you don't get them right, you don't get the GELO. But it doesn't show up in your transcript. It doesn't affect you in any way. It's just a statistic that we like to track. Academic integrity. This is super important, especially right now with the whole hybrid online thing. I know it can be really tempting to Google or to phone a friend or to do things that we know are not kosher in this online setting. I'm pretty ruthless about this. I haven't had to conduct like an honor trial in a few months, and I don't enjoy them, but I don't hesitate to start them when they are called for. So please just be honest, right? Don't cheat. I'll work with you as much as I can. If a test doesn't go well, or if you're expecting a test to go badly, talk to me ahead of time. I will work with you a lot to make sure that things do go well. But if you try and cheat and show me work that is not your own, then I don't have a problem, running it up the flagpole. I hate that shit, but I'll do it. So let's keep everything nice and honest. These are the rules that you're required to know, so you should know them. I suggest taking a look. ADA, so the Americans with Disabilities Act. If you're registered with the DRC or you intend on registering with the DRC, or you have a disability that you think would give you any testing accommodations or other academic accommodations, please let me know, whether that's like a note taker or a quiet environment to test or extra time on tests and quizzes, whatever it is, talk to the DRC and also talk to me. So the DRC does not reach out to me and say, hey, this student wants to do this or that. You guys have to reach out to me and let me know, and then the DRC will confirm. They'll be like, oh yeah, that's the accommodation we have for this student. If you already requested a testing contract through the DRC, we still need to talk, because in that testing contract, they ask me to specify a few things that I need to ask you about. For example, if you are entitled to a longer test time or a special test environment, we need to decide whether you want to do that through HonorLock or through Zoom with the DRC. That's your choice. And so even if we already have a testing contract submitted or established, please send me an email or a Canvas message so we can talk through that stuff. Accessibility, same sort of thing. If you have a hard time reading what shows up here or hearing what comes out the speaker or any sort of issues with accessibility, The DRC can help. Thankfully, all of my materials are put together in LaTeX, which is really, really friendly with screen readers and stuff. So talk to the DRC folks, and I will do everything I can to work with them and work with you in the event that they have any sort of accessibility challenges. Discrimination and harassment, this should go without saying, but don't be an asshole. Just be good. Be kind to me, be kind to your fellow students, be kind to faculty and staff in general. Everybody should just be good to each other. The rules are here and you should know them. Similarly, student rights and responsibilities. These are rules that you are being judged by constantly, so you should know them. You should know the sort of things that the college could get angry at you for. You should know the sort of things the college expects you to do. So I definitely suggest taking a look at each of these links, especially this one and the academic integrity one. And then we get to the calendar. So this is roughly the order this is roughly the pace we're gonna go through things. I may speed it up or slow it down a little bit at certain places, but this first week we're going to talk about 5.5, which is U sub, 6.1, which is areas between 6.5, which is average value. Next week we're going to talk about 6.2 and 6.3, which are on volumes, and then we might talk a little bit about 6.4, which is work, a concept from physics. And then the week after that we're going to start on chapter 7, which is all on methods of integration. Once we finish all the way through chapter 7, we will be ready for exam 1. Exam 1 is going to cover all this shit. Right? It's fairly straightforward. So 5.5, 6.1, 6.5, 6.2 through 6.4, and then 7.5. After that, we're going to start on the middle part of the class, which is like the convergence part of the class, where we talk about improper integrals, infinite sequences, infinite series. This tends to be the part of Calc 2 that scares the most people away. So make sure that after exam 1, you come in ready to work real hard. Really, the hardest part of this class is power series and Taylor's theorem. This stuff I used to put on exam 2. I now put on exam 3 to split it up a little bit. If you work really hard on these things, all of the basic convergence stuff, then this stuff will not be super hard. But if you don't work hard on this convergence, sequences, series, and proper integral stuff, then this will seem like alien chicken scratch. So when we finish exam 1, you're going to notice a change of pace in the course. The course is going to get considerably tougher because the material is going to be totally new. It'll be stuff you've never seen or even maybe seen anything like at all in the past. So just be prepared for a little bit of a step in difficulty, a little bit of a jump in the amount of time that is expected of you after exam 1. After exam 2, similar sort of thing where we talk about power series, but then things kind of calm back down and the last few weeks are a little bit easier. So there's a definite rise and fall to this class, and the middle is the hard part. I know Calc 2 has a reputation for being really challenging. It's my favorite class to teach for sure, because the material is just so damn beautiful, but you have to put in a lot of time. Big things, definitely stay on top of the homework. Do not fall behind in the homework. That is what kills most people who get in trouble here. It's just a matter of committing the time, right? Spending enough time working on these things and struggling through them, using your own mind. It's fine to use notes and look through the book and all that stuff, but make sure you're not moving on from something without fully understanding it. All right, any questions about the syllabus? So remember, if you want to ask a question, you can either hold down the space bar to unmute yourself and talk, or of course you can type in the chat.
When do you think office hours will be posted?
That is the next thing I want to talk about. You pulled the words right off my doc count. So possible office hours. Right now, let me give you a feel for what I'm looking at. I'm going to talk with each of my classes. Right now I'm planning to do a 12 to 1 hour on Tuesday and Thursday, a possible 3:30 to 4:30 on Wednesday, and a 2 to 3 on Friday. I do have room to add a few others. My Tuesdays and Thursdays are pretty open. My Monday, Wednesday, and Friday are very full. So other times that I could add would be a 3:30 to 4:30 on Monday, or what else? We could do later stuff also, anything after that. But first, what I would like to see is there anybody who could not make at least one of these four? So I want to start there.
I can't make Wednesdays. That's only.
But is there anybody for whom none of these work? So my goal is to make sure everybody has at least 1 hour per week, 1 office hour per week that they could attend. So is there anybody who can't come to any of these?
Well, I work until 5:30, so I mean, unless I go in during work, I don't think I can make it. Be anything after 5, I can do 5 if that works with you.
Okay. So maybe I could see about adding like a 5 to 6 on Monday. Or we could talk about extending the Wednesday, maybe 3:30 to 5:30 or something like that.
Yeah, that works with me. I mean, at least to make sure it's convenient with you, of course. Like, if anything, I can just talk to you one-on-one. I don't mind.
Oh, so I'm a little bit hesitant to do late stuff on Mondays, Wednesdays, and Fridays, just because those days for me start at 7:30, which is a little bit early. But I don't mind doing something like this. The main priority here is to make sure that everybody has at least 1 hour that they can make.
So if it's uncomfortable for you on Monday, Wednesday, and Friday, we can always do it Tuesday or Thursday.
So a Tuesday, Thursday evening might work a little better? Maybe like
Yes.
a 5 to 6?
That's fine with me. Yes, sir.
Okay. So is there anybody else? I'm going to box the ones that have made it through a few rounds of selection so far. Besides Sergio, for whom we just added these potential new hours, is there anybody who cannot make at least one of these boxed hours per week? Is there anybody who's not free during any of the boxed times? And if so, what hours would work? Okay. So for now, I'm going to plan to add the Tuesday, Thursday, 12 to 1, the Friday, 2 to 3, and the Wednesday, 3:30 to 4:30 hours. And then I'll think about which of these would be the most convenient to add. It may end up being this guy. Probably will end up being this guy. But we'll have to see. I have to talk to my other classes too and figure out what works for them and what does not work for them. All right. So that's the plan for office hours. By the end of this week, I will come back and update the syllabus. I'll also update this page in Canvas here. So once I have the office hours established, the drop-in hours will be here, and then a link to take you to that office hour will be here.
I'm sorry, are the office hours in person or online only?
For now, they're going to be in Zoom. Yeah, so they'll be just like this, only I'll use a waiting room and bring people in one at a time. And then eventually, I'm hoping, so I did ask permission over the summer to do in-person office hours. I was told no. And I asked a few weeks ago, can I do them in the fall, in-person office hours? And they said no. But then just the other day, I got a notification saying that they have a classroom reserved next to my physical office where we could do occasional short meetings with students, which to me sounds a lot like office hours. So I have to kind of see what the department and the college are willing to let us do. We're going to start out with all the office hours being in Zoom, but if I am able to build an in-person office hour into one of these, I absolutely will. It's just right now I don't have permission to do so. So for now, office hours will be online and Zoom. But hopefully within a few weeks here, we'll have something in person. All right. Any other questions about this kind of bookkeeping, how things are going to run, where your grades come from, all that good stuff? What are we doing in this class? You know?
So I have a question actually concerning the access code for WebAssign.
Mhm.
I bought a multi-term pack over the summer for my Calc 1 class, and I don't know if it carries over or what happens with that.
It
But
will, yeah.
okay, so should I just call their company to make sure it carried over, or?
You can if you want to. You can reach out. You can reach out to their support group.
Okay.
But I think also if you just go to webassign.net and you the enter class key option there instead of the login option, you can put in the class key and that'll let you sign in. And if you have paid for access, you should be good to go. So you can go ahead and just try to register for our class in WebAssign, and it should just let you in. But if it does not, then definitely reach out to the help folks at Cengage at webassign.net, and they'll walk you through it.
Okay, thank you.
Of course. Any other questions about this stuff? Anybody want to talk a little bit more about WebAssign or any of those things? All right then. That's nice because that means it's time to talk about some mathematics. So the first few sections we're going to cover is stuff that you're supposed to learn in Calc 1. But I know not every Calc 1 class gets to those things. For example, the Calc 1 I did over the summer, we didn't get to talk about section 6.1, but some don't even get to 5.5. So I want to make sure that we're starting off with a good understanding of substitution. So substitution, or U sub, is a method of integration. Basically, you can think of it as the backwards chain rule. Remember how the chain rule for derivatives work? U sub is basically a backwards chain rule. What you want to do is look at, you have some integral here, and maybe you've got something kind of complicated tucked inside of an outer function, like maybe something like this. And then over here, you happen to have something that looks a little bit like the derivative of your inner function. So remember, the differential dx tells us what variable we're integrating with respect to. This is called the integral symbol. It's a nice elongated Latin S, just like the S that we write when we write the word section. It's just stretched out. And here I want to integrate the function square root of sine x times cos x. Unfortunately, there's no obvious way to find an antiderivative for this integrand. This is the thing you're integrating. The function inside the integral is called the integrand. And here, there's nothing that I recognize immediately as having this as its derivative. This is kind of complicated. But here, if this wasn't a square root of sine x, if it was just a square root of x, that would be pretty easy to integrate. And it happens to be the case that the derivative of the inner thing here is floating around out here, which means this looks like the sort of thing that would come as the result of a chain rule derivative. So it's a good candidate for integration by substitution. The way I like to do my substitutions is I put a little box over here on the side, and inside that little box I put all the stuff I need for my substitution. I want to get rid of the complicated stuff under the square root. So I'm going to substitute for that. I'm going to let u be the sine of x. And then I calculate the differential du by taking derivatives. The derivative of sine x is cos x. So du dx would be cos x, which means du is cos x dx. I put all this good stuff I need for my substitution in the box, and then I try to figure out how to plug it in over here. The cardinal rule for substitution: everything must be changed into the new variable before doing any integration. So if you have bounds for your integral, if it's a definite integral, you got to get rid of those old bounds and change them into bounds for the new variable. Your integrand, the function you're integrating, has to get rid of all the old variables and have only the new variable. So no x's, only u's. And then your differential, the dx thing, you got to get rid of that and swap it out for a du thing. Now here we're lucky. Cos x dx, this is exactly du. And the square root of sine x, this is the square root of u, because u is sine x and du is cos x dx. So this one works out really easily. This integral is equal to integral of square root u times du. Couldn't possibly be nicer. And from there, we know how to handle things. This is definitely an integral we've seen in Calc 1, even if our Calc 1 didn't get very deep into integration, because the square root of u is a power function. It's just this variable raised to that power. It's u raised to the 1/2 with nothing more complicated going on. Because it is a straight power function, I can use my straight power rule to find an antiderivative. Remember, the power rule says if you want to find an antiderivative for a power function, you add 1 to that power, and then you divide by that new power. Sorry, this camera's having a little hard time focusing. Focus, you fuck. So I add 1 to the power, I divide by the new power. That is my antiderivative step. So I stop writing the integral symbol. There's no more integral symbol or du, but I do need to start writing a plus c. Because remember, an indefinite integral, an integral without bounds, is asking for all the functions whose derivative is this. And of course, the derivative of any constant is 0. So here we think of c as being what's called an arbitrary constant. And then I can clean things up a little bit. 1/2 plus 1 is 3/2. So that's u to the 3/2 divided by 3/2 plus c, which is the same if I flip and multiply this fraction, that's 2u to the 3/2 over 3 plus c. And then finally, because it is an indefinite integral, no bounds, I have to go back to my original variable. So, you know, somebody asked me a question about x's and I gave them this answer, they would be like, what the hell is u? Oh, okay, u was sine of x. So this is 2 times the sine of x raised to the 3/2 power all over 3 plus a constant. All right. So that's this first little example on the substitution rule. This is how you do an integral by u sub. What you'll see is I actually don't like to use the letter u a whole lot for my substitutions because we use the letter u when we talk about integration by parts and it's easy to get confused. So for most of the other examples you're going to see here, I'll use the symbol Z for my substitutions. Okay, any questions on this problem? Like how we chose this substitution, why we needed this, how this became this. So I'll go through those in order. We chose to substitute u equals sine x because here I've got a slightly complicated function. It's a composite function, right? An outer and an inner piece. The outer piece here is the square root, and the inner piece here is sine of x. So I think, oh, I would like to make this simpler. I would like to make the inside here just my variable. So, okay, that's how I chose to substitute u equals sine x. Then I always need to calculate the differential. If you're making a substitution, you always need to calculate the differential because remember our rule is everything has to be changed into the new variable. Conveniently here, the differential du is cos x dx, which is exactly what was lying over here. If I didn't have this cos x here, this substitution wouldn't be able to go through, or it would be harder to make it go through. I'll look at an example or two like that in just a minute. So now I recognize, okay, this whole piece, that's just du. This whole piece, that's square root u. So I can rewrite my integral as integral of square root u du. And now I've just got my new variable. No x's floating around here, that's important. I realize that my new integrand is a straight up power function, which means I can use the power rule. And of course we tack on our plus c. Then a little bit of algebra simplification. And finally, because it is an indefinite integral, we have to plug back in for u. So u was the sine of x. So instead of u to the 3/2, I have sine of x to the 3/2. And you could always check your work. You could always take the derivative of this and verify that you get this. It's not a bad idea, but I'm not going to do it here. So let's look at a slightly trickier example. I'll precede my examples with the abbreviation EG, which is Latin for, here's an example, exemplus grati. Lots of examples or many examples exist. Let's try something like, how about, you don't know how to do that yet, so we should do something. So here I've got a polynomial function, x squared, times the secant of x cubed times the tangent of x cubed. And we're integrating dx. So we're integrating with respect to x. Come on, camera. Come on. Get your shit together. Get it all in one place. Put it together. All right. Okay, so what could I try substituting for here? What looks like an inner thing, an inner function that I would like to get rid of to simplify this integrand? So I'm going to try to block out some of this light and see if that helps. Yeah, much better. All right. This light. So you can hold down spacebar to shout out ideas, or you can just type in chat. Anybody have an idea what we would like to try?
Can't you do x cubed because the derivative of x cubed is 3x squared?
Good, yeah. So my inner functions here are x cubed. No doubt this is a composite, secant something times tangent of something. And in both of those guys, the inside is x cubed. So I'd like to get rid of that inside. I'd like to make that simpler. And conveniently, something very close to the derivative of x cubed is hanging out over here. So I'm going to I'll use the letter u one last time here. I'll let u be x cubed So then du is 3x squared dx. Why is this good news? Well, the bottom guy down here tells me that 1/3 du is equal to x squared times dx. I'm going to write it like that. Because here, everything is being multiplied. X squared times secant of x cubed times tangent of x cubed times dx. So I could reorder this as integral secant x cubed tangent x cubed times x squared dx. And when I make this substitution, I get an x squared dx. X squared dx, if you divide both sides here by 3, is 1/3 du. So this piece isn't exactly du. This piece is 1/3 du. And this piece is secant u times tangent u. So my integral does get nicer when I make this substitution. I'll come down here. So some notation tricks. Only ever put equal signs between things that are equal. And if you want to continue an equality off a line where you run out of space, use the ... dots. So this integral is equal to integral secant u times tangent u times 1/3 du. What can I do with that? What can I do with secant u tangent u 1/3 du?
You can move the 1/3 to the outside of the integral.
Good. Again, because everything here is being multiplied, 1/3 is a factor of the integrand. In other words, it's a constant multiple of the thing inside the integral. So the 1/3 can come out, because the integral is a linear operator. Constant multiples come out. And then inside, I'll just have secant u tangent u du. And the question is, can we think of an antiderivative for secant u tangent u? Who has secant tangent as his derivative?
Secant square.
I'm sorry, I just couldn't quite hear your demo. What did you say?
Oh, never mind, never mind.
So who differentiates to secant tangent? Think about your trig functions. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is secant tangent, right? So this is 1/3 secant u plus c. Because secant is an antiderivative for secant tangent. The derivative of secant is secant tangent. And then finally, we have to plug back in what was u. U was x cubed. So this is 1/3 times the secant of x cubed plus c. And like I said at the end of the previous problem, you can differentiate this to check. If you differentiate this, the c will differentiate to 0 because it's a constant. The 1/3 will pop out because it's a multiplicative constant. The derivative of secant is secant tangent, so you'd have secant x cubed times tangent of x cubed. And then by the chain rule, you would have to multiply by the derivative of x cubed, which is 3x squared. The 3 and the 1/3 will cancel, and you get secant of x cubed times tangent of x cubed times x squared, which is what we started with. So this is good. Questions on this? So at this stage, Solomon asks, where did we get the 1/3 du? First, I just take my u is x cubed, and I differentiate on both sides to get the differential. Du is 3x squared dx, because the derivative of x cubed is 3x squared. After I get to this point, though, I have to go, okay, well, shit, how am I going to use that? I know that I need to swap the dx stuff for du stuff. So then I come back to my integral and I ask, all right, how can I get a 3x squared or an x squared dx out of this? And I see, oh, well, I've got an x squared here, and I've got a dx here, and everything's being multiplied, so I can rewrite my integrand in this order. And then I get an x squared dx. So I go, okay, du is 3x squared dx. So if I want to isolate the x squared dx term, which is what I have here, I should divide both sides by 3. So x squared dx is what I have available, and I need to write that in terms of du. So I isolate the x squared dx by dividing both sides here by 3, and I get that 1/3 du, or du over 3 is x squared dx. Another way to do this is to solve this for dx. You could get dx is 1 over 3x squared times du, and then you could cancel the x squareds. That works okay, as long as things don't get too complicated. But generally, when I try to transition people from thinking about this in a Calc 1 way to thinking about this in a Calc 2 way, I suggest rewriting the integrand so that the stuff you think you're going to use with the differential in the substitution is set next to the dx over here. And then I try to solve for whatever this is in my differential relationship. So I think I'm going to use the x squared in my differential part of the substitution. So I write that next to the dx, and I say, okay, I've got an x squared dx to work with. How can I get x squared dx out of this? Ah, divide both sides by 3. Does that make sense? Cool, okay, cool. Let's try another then. And let's make this a definite integral. Maybe nothing too terrible. Why shift it this way? So this is, first note that this is a definite integral. It's got bounds or limits of integration, which means that my answer here should just be a number, not a function. There shouldn't be any plus c's. We're going to find an antiderivative, and then we're going to evaluate that antiderivative between bounds. Another worthwhile thing to note here, the square root of x minus 1, this is not the square root of x minus 1, like that. You cannot distribute square roots. Roots and powers never distribute over addition or subtraction. So I can't like distribute that square root and then call this a power rule thing, right? That does not work, because algebraically this step is just straight up not kosher. It's a mistake I see a lot in the Calc 2 level, because it's something that would make a lot of our integrals a lot easier. And so I think people just kind of forget that you can't do that, but you definitely cannot do that. So instead I want to ask, how can I make this nicer? Well, I would love to not have any addition or subtraction under my square root. That's kind of why this sucks. So if I think of this as my inner function, I can try substituting Here I'll use the symbol z instead of u, and I'm going to let z be x minus 1. If I differentiate on both sides, I find that dz is just dx because the derivative of 1 is 0. But also, this is a definite integral. And I know your Calc 1 teacher may have told you something different. The rule in Calc 2 is you must change your bounds. You can't like ignore the bounds and then go back to the original variable at the end and evaluate between the original bounds. No. Anytime you make a substitution in a definite integral with bounds, you've got to change the bounds. So let's look at my old bound. When x is equal to 1, z is equal to 1 minus 1, which is 0. So my old lower bound was 1. My new lower bound will be 0. What about the upper bound? When x is equal to 2, I look at my substitution here and I just plug in 2 for x. When x is equal to 2, z is equal to 2 minus 1, which is 1. So my old integral went from 1 to 2. My new integral will go from 0 to 1. And unless I change the bounds, these are not equal to each other. So you must change the bounds. The square root of x minus 1, I'll leave some space there at the start. The square root of x minus 1 is just the square root of z, because z is x minus 1. And dx is just equal to dz. But what about this piece? So this piece is root z. This piece is dz, but I still have to contend with him. What can I do with that x? Can I just leave it like this? Is that kosher?
No, because that would mean they're like two different variables, right?
Exactly, yeah. Remember kind of the cardinal rule here is that you always, always, always need to get everything in terms of the new variable before integrating. So if you have this as an in-between step, that's okay. Just remember that you really can't do shit until everything is in terms of z. So I need to get this guy in terms of z. Do I have anything that tells me how x and z are related to each other?
Could you, on the first equation, bring the 1 over and do 1 plus z?
Exactly. If z is x minus 1, then z plus 1 has to be x. So before I'm able to integrate, I rewrite that as z plus 1 times the square root of z dz. And now I'm in good shape. Because while I can't distribute the square root, I can distribute the z plus 1 because he doesn't have any wonky power up here. So my next step is going to be to rewrite square root z as z to the 1/2. So this is the integral from 0 to 1 of z plus 1 times z to the 1/2 dz. And you see I cross my z's. I recommend you do the same. That way they don't get confused for 2's. And now I can distribute. This will be integral 0 to 1. Z to the 1/2 times z to the 1 is z to the 3/2 plus z to the 1/2 times 1 is z to the 1/2. And now I'm ready for an antiderivative. an antiderivative for z to the 3/2 comes from the power rule. Add 1 to the power, divide by the new power. 3/2 plus 1 is 5/2. So that's going to be z to the 5/2 divided by 5/2. And then this plus is this plus. 1/2 plus 1, if I add 1 to the power of z to the 1/2, I get z to the 3/2. So this will be z to the 3/2 divided by 3/2. And that's my antiderivative, which I will evaluate between these new bounds. I don't need to go back to the old variable, and I don't go back to the old bounds. I do everything in terms of the new variable and the new bounds. So there's no need to plug back in for x's here. We just take this whole expression and evaluate it from 0 to 1. We can clean it up algebraically a little bit first, and I would recommend doing that. So this is the same as 2 times z to the 5/2 divided by 5 plus 2 times z to the 3/2 divided by 3, evaluated from 0 to 1. And then remember the way the evaluation goes, you plug in the upper bound. And then subtract from that what you get when you plug in the lower bound. And what you'll see here is that everything here is 0. Because 0 raised to any positive power, and 5/2 and 3/2 are both positive, is always 0. So this whole term contributes nothing. And 1 to the 5/2, 1 to the 3/2, those are just 1s. This is 2/5 minus 2/3. And that's it. So nowhere did we need to go back to the old variable. And you must change the bounds. If you wrote this same integral with the original bounds from 1 to 2, it would be incorrect.
Professor, would that be minus 2/3 or plus 2/3?
Oh, I'm sorry, plus 2/3. Thank you. Yeah, this plus. Thank you. Yeah, good. Any questions on this problem? Okay, how are we doing for time? Oh, I think we are right at time, aren't we? This is 9:30 to 10:45, right? Okay, so this is where we will finish it. We'll leave it here for today. Watch WebAssign. For homework 1. It'll open today. And it's due next Monday at the start of class. If you haven't bought your WebAssign access code, that's okay. Just go ahead and act as though you have one. Start registering. And when you get to the page where it asks you for an access code, scroll down to the bottom and click the temporary access link. That will give you access for 2 weeks. So 2 weeks from today, if you haven't bought an access code, you will get kicked out. But there's no excuse for not getting in there. Everybody needs to get into WebAssign today and at least take a look at homework 1. It's not open yet. I haven't had time to put it together yet, but I'll have it for you in just a little bit here. So please, everybody, go ahead and create a WebAssign account if you haven't yet. Sort out whatever issues you have with your access code, whether you bought a multi-term access previously and you want to know if you can reuse it, just go ahead and try. If it doesn't work for you right away, contact WebAssign's support. If they give you any sort of hard time, send me a message and I'll call them up and lean on them a little bit. But I would like to see everybody into WebAssign today, and I would like to see everybody having at least downloaded homework 1 by our class on Wednesday, okay? Any questions for me before we get out of here? Oh, this should be a plus. Sorry. Plus, yeah.
Yeah, Professor, I have a question for you, but it's kind of like not related to what we learned today. It's kind of related to my situation. So if you want to talk about that later, I understand. But I don't mind saying it now. That's okay.
Let's see. So I do have another class to get to, so maybe go ahead and send me an email about that, Sergio, all right?
Yeah, you got it. You got it. I'll send you an email then. Cool. Thank you.
Of course. Okay, any other questions or questions about the class, questions about the material we talked about today? Alrighty then, so I will go ahead and stop the screen share here. This meeting was recorded and all of our meetings will be recorded. So I'll be posting that to YouTube as soon as it's ready, but it will probably be a little while because the computer has to compile it and then YouTube has to do their own processing. If you haven't typed anything in chat, do go ahead and make sure you've done something in there. That way I can mark you as having attended for financial aid purposes. And that is it, ladies and gentlemen. I will see you on Wednesday.